my first question is, how did the universe start?
Oh, jeez. Right from the beginning.
Blatantly
Yes,
asking
right from
that
the
question. He's looking at you. Who knows
We
what
can't
the
get
answer's
more
Yes.
to the start than that,
Yeah.
right? Okay, so the universe started with something called the Big Bang.
Yes.
All right, it's as far back as we know. So basically, what happened, right? As astronomers were looking at all the galaxies and the stars, they noticed that all galaxies, right, were actually moving away from us. Okay, so now, if all of them are moving away from us, so let's say if we forward it, let's say 1 billion years, then all the galaxies would be where?
Far apart, really far. Yeah.
1 billion years further away from us. Now, instead of that, let's rewind it 1 billion years.
Yeah.
What would the universe look like then?
1 billion years closer than it was. Billion
Yeah,
years.
so those galaxies, planets, whatever is out there, right?
Yeah.
Would be closer. And if we go another 1 billion years, closer.
Oh, so it must have all happened from one point when they were all...
Yeah, so if we rewind the clock far enough back, right?
Yeah.
There should be a point when all the galaxies and everything in the universe were just on top of each other.
Yeah.
Squeezed into, let's say, a tiny little dot. Okay? Now that, we'd have to rewind the clock about 14 billion years. Okay?
Which is ages.
It's like 13.8 billion years, if we're being technical.
Still ages.
Right?
Technical.
13.8 billion years. So what we assume is that the universe was way smaller and just confined in a little dot. Something happened 13.8 billion years ago.
Some sort of flash in there. Yeah.
Now we're talking about before time even began.
Yeah.
So everything that we know, right, has sprung out from that one instant, and it's expanded to 13.8 billion years, and that's where we are now. But when I say everything began, it's also that's when space started, as in the space you move in. There was no space before that. There was no time before that, because as far as we know, time started at that instant. So to say, which I'm sure this might be one of your questions, what happened before the Big Bang actually doesn't make sense, because there was no time.
Yeah, my next question was actually going to be, where was that dot if there was no space?
Great question.
Yeah.
So because see, now the question itself, though, now this is getting very philosophical, right? Right from the start, we love it, right? The question itself, now this took when I've heard physicists talk about it, it took me ages to even like wrap my head around this. But there was to even ask where it was implies that there was a space, a place for it to be, but there was no such thing as a place yet.
Okay.
So you can't ask where it was, because everything space itself started at that instant, and even time started at that instant. So
So I guess there isn't really such thing as nothingness, because there's always got to be something there. Like in space, you could say it's nothingness and like voids and stuff, but it's just vacuum, right? But that's still something. Yeah. That dot would have still been in something. It was been a place.
Everything.
Yeah.
Okay. But even like the whole idea of there being nothing. I've been reading this book on quantum mechanics, which completely blows that away as well. But even in a vacuum, right, they may not be particles, but there are forces. So there's gravity in the vacuum. There are fields of forces. So the electric field, the magnetic field, it is in a vacuum.
Yeah.
So even the idea of this is already trippy. So even there's no such thing as nothing.
Yeah.
So we've already had no such thing as nothing, no time before the Big Bang,
and then no place.
No place before the Big Bang.
But if there's
we're about 2 minutes in,
no such thing as nothing. 14 billion years ago, there was nothing.
But there was no.
There was something. There was that.
I guess for you to say that there's nothing, there has to be something to be
relative
matter.
To nothing.
Relative to what?
And
right?
that matters what the universe is growing into right now, I guess.
Now that's another question that doesn't make sense, because if space is created at the Big Bang, So what is the Big Bang growing into does not make sense. Because, no. There's no into out there anything. You're talking about something that is existing outside space as we know it, though. That's the main thing. We don't, obviously, no one was around, right? So we don't know this yet.
Might have been.
Oh, jokes.
Why did you ask me?
Another question?
What made me? I was there in a way.
Yeah.
So were you. So in that tiny thing that was in nothing, that we don't really know where it was because it wasn't anywhere.
Yeah.
That created everything.
Yeah.
Some of that everything that it created. Is me. And you.
That's true.
So you were there.
Yeah.
Yeah.
So
you
why
just
don't
don't remember it.
Yeah.
That is actually a great point there.
Yeah.
So everything, every atom, not even atom, goes smaller. Every quark, every electron, everything was there in that instant.
Yeah.
In some form.
Yeah.
Okay.
I wouldn't have.
It wouldn't have been as.
You wouldn't have looked like that.
Yeah.
It wouldn't have been as matter though, as something that occupies space and weighs something. It would have been as energy. So it's just pure dot of unimaginable energy.
Yeah.
Sitting nowhere.
Yeah. And at no time, right?
Yeah.
Okay, so
Honestly,
this is a great start for
It's like
episode
sci-fi.
1.
if we do this again in 200 years, we might have a better answer.
Yeah.
And you might have found it.
Yeah, and you might even be alive then. That's a whole other thing. Yeah.
That's
So
let's not go there.
so there is energy. Explosion, and it was incredibly hot, obviously, right? This big, massive explosion. Now, the scientists actually don't know. They start at there is a time that they start where they can actually now start predicting or not predicting, but the past.
Predicting.
Right. Okay, so they can start their assumptions from a certain point. And it's something like 200 milliseconds or something, right? Before that, though, they don't. This is all hypothetical. They were just guessing.
Yeah.
I'm not guessing, but there's a little bit informed guessing.
Educated guess. Educated guess.
So this energy is really hot. The universe is too hot. It's too hot for there to be matter yet. Stuff, as we know it, atoms. And then energy cools down. As the universe cools down, now energy can condense into matter. Like how water, steam, right? You breathe onto a cool piece of glass and the water vapor in your breath cools and turns into liquid water, right? In the same way, energy condensed into matter.
Yes, it was all condensed into that tiny dot, and then something happened, and then it just
it existed. So there's energy and matter are interchangeable. That's what Einstein, that famous formula,
E equals mc squared.
Oh, there you go.
Energy equals mass times the speed of light squared.
Oh, look at that. Yeah.
Go home now.
So what that tells us is it's not just a way of relating the two, right? So you can take energy and you can turn it into mass. Matter,
just a way to,
and then in like a nuclear bomb, we take matter
and then turn
it into energy.
So it's just
it's interchangeable. It's kind of the same thing. It's a different states of one.
Yeah.
But what did it explode into?
I got that. So every atom. So I can't remember how many particles. Last time I counted.
Last time you counted.
Right?